Hi. In this lesson, we're going to talk about the measures of central tendency. The first thing we're going to look at is finding the mean. The mean of a set of data is the sum of all the values in a data set divided by the number of values in the data set. It is also referred to as the arithmetic averages. So, how do we get our data? We're going to add all the data together and we're going to divide the data or the sum by the number of data we have available in the set. This is the formula. So let's look at this data set. We have 17, 10, 9, 14, 13, 17, 12, 20, and 14. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So we'll say the sum of all the data divided by how many data sets we have. We'll have 126 divided by 9, giving us 14. Now, what can we do to change the mean? We can add a number. If we add a number, you will see that the mean is directly proportional to the sum and inversely proportional to the number of data sets that we have. So by adding a number, we'll be increasing the sum. And even though the number at the bottom will also increase, it only increases by 1. So the overall mean is going to increase. We can decrease the mean by subtracting a number. So what's going to happen is that the sum of all the numbers is going to decrease. So will the number of data points, but the top part is going to decrease more than the bottom part. So your mean will go down. We can increase and decrease the mean by adding and subtracting. Adding and subtracting data sets, that is. Next, we'll talk about finding the median. The median of a set of data is the middle element. When the data is arranged in ascending order, we have to determine the median by putting the data in order first from smallest to largest, and then we're going to determine the number in the exact center. If there are odd numbers of data points, the median will be right in the middle and will be absolute. Whereas if we have an even number of data points, the median would be between two number points, and we would have to add those two and divide them by 2. Example here, we have data points. There are 9 data points in this data sets. So we will go ahead and rearrange them, and we will look for the middle number. So there's 4 numbers in the there, 4 numbers to our right, 4 numbers to our left. The middle number is 14. So therefore, the median is 4. It's 14, sorry. So we can also change the median. If we add a data point on this side, what's going to happen is that your median now is going to shift and be between 14 and 14. So likely for us, if we add 14 and 14, we will have 14 again, but sometimes we're not so lucky. We're going to have 14 and 15 maybe, and our middle number would be 14.5. So either way, we should see an increase if we just add a number and it's not in this sense. So in this sense, it was lucky because we're going to end up with 14 and 14, but sometimes we end up with 14 and 14, we end up with another number, let's say maybe 14 and 16. And then our median would be 15, so it would have increased. If we then add a number on this side, say somewhere around 8, our median will shift towards this side. So now the median would be between 13 and 14, giving us a median of 13.5. Okay. Next thing you're going to do is finding the mode. The mode is the most frequently occurring measurement in a data set. There might be more than one mode. We say if we have two modes, we have a bimodal mode, or we have multiple modes if it's more than two. So what we're going to do to find the mode, we're going to arrange them from smallest to largest as we did when we're finding the median. Then we're going to look at our data sets and see which number is appearing more than once. Then we're going to take that as our mode. Let's look at our data set again. Here it is rearranged. We will notice that 14 and 17 are repeating themselves the same amount of times. So they're both the modes. This is a bimodal data set. It could happen that maybe we have one extra 17, then 14 in this case will no longer be considered a mode, only 17 because 17 appears more frequent than 14.